My dear students, this lecture is on solar distillation process, right? So first let me explain what is distillation. You see, distillation is a process of separating components of a mixture based on different boiling points, right? Let me explain it further with certain example. Let's say mixture consists of two components A and B, and suppose A has a boiling point of say 50 degrees centigrade and a component B has a boiling point of 100 degrees centigrade. So if the mixture is heated to a temperature more than 50 degrees centigrade, then what will happen? Component A has 50 degrees centigrade temperature, so all of this component A will be vaporized, leaving behind the component B. Now, if the vapors of this component A are cooled down and then they are collected, then this is how the components A and B can be separated. Now, what is required in a distillation process? Energy to, to heat the mixture. Likewise, in case of solar distillation process, exactly the same distillation process is followed, but the energy comes from the sun. That is, the solar energy is used as a heat source here, right? Now, if we want to use the solar distillation process for purification of water, say you have impure water full of contaminants, uh, if the energy is supplied uh, to this impure water full of contaminants from this solar energy, then the water will be evaporated, leaving behind all the solid impurities, including all kind of salts, microbes, and waterborne pathogens. So, so the water vapors thus so formed are then cooled, they are condensed, and then are collected. So this is how the water that you get after the solar distillation process is is a pure purified water that is drinkable. Now this process is also called the solar desalination because this is used to desaline the saline water. What is saline water? The saline water is the water which contains excess concentration of the dissolved solids, right? So this is also called the solar desalination process. Now, uh, so first two bullet points I have already covered. The third bullet point is the device which utilizes solar energy to convert impure water or saline water to pure drinkable water through solar distillation process is known as solar still. So that particular device that we use for purification of water by using the solar distillation process is called the solar still. Now let's see what is the basic principle of the solar distillation process. So here you can see that this figure 1 shows the schematic diagram of the solar still, and figure 2 shows the prototype solar still. Now here you can see that in a solar still, uh, there is a basin. A basin is nothing but a shallow water reservoir, and there is a sloping glass cover through which the sun radiation enters into this enclosure. Now this basin contains the impure water, right? This is in figure 2. You may see that one of the pictorial view of a prototype of a solar cell. Here you can see this is a glass cover, right? So, let me come to the second bullet point. It consists of a basin and a sloping glass cover. I already explained it. Third bullet point says it operates using the basic principle of evaporation and condensation, as shown in figure 1, which replicates the natural hydrological cyclic process through which nature makes rain. I hope all of you knows the natural hydrological cyclic process. However, I still explain it in brief. This process, this natural hydrological cycle is also called the water cycle. This cycle refers to a continuous motion of water from Earth to atmosphere and then atmosphere to Earth in a cyclic process. You see, all the water bodies like uh, ponds, rivers, sea, the water from here, these water bodies gets evaporated due to the sunshine, and as the water evaporates, it rises to the atmosphere, then it goes high above. Then all of us know that as you move upward toward the sky, the temperature goes down. So as the water reaches to high up in the sky, it gets condensed because the low temperature there, and then it as this condensed water gets heavier, then it comes down through rain to the atmosphere. So this is how the this water moves from earth to atmosphere through evaporation process, and then condensation takes place at the uh, high of the sky, and the condensed water that you get at the high of the sky is the pure water, right? So this exactly the in similar way, uh, the evaporation and condensation principle is used in a solar still, right? So here you can see that. Let me explain with the help of this figure. This basin has a impure water or contaminated water. So as the sunshine, heats this impure water, the evaporation takes place. Then you see, then what happens? Let me explain it with the help of the bullet points. Now come to the fourth bullet point. The solar still contains impure water or saline water in the basin, and as the sun rays penetrate through the glass cover, it raises the temperature of water, which results in evaporation of water, that as I already explained. Okay. Next bullet point is the water vapors rise towards the glass cover, right, and condense on the underside of the glass. Here you can see that, because the glass cover has relatively lower temperature because it is exposed to the atmosphere. So here, as these vapors reaches to the glass cover, then these vapors gets condensed on the underside of these, this glass cover, and runs into a collection channel, and then into an enclosed container. So these condensed droplets, because there is slope in the glass cover, so this slides down. Then there is a collection channel over here. So in this figure, you can see the collection channel over here. You see this here. You have the upper edge, this upper edge of this glass cover. So corresponding to this upper edge, you have this edge of this glass cover, and this is the bottom edge of the glass cover, right? This now along this edge there is a collection channel. So below this surface, you have a channel which is sloping from here to here. This glass in this collection channel has a 3 to 4 degree slope from here to here, so that all the collected water, dips down to this side. Then here you have a outlet for the pure water, right? The okay. Now next point is, when the water evaporates inside the solar still, it leaves all contaminants, salts and microbes behind in the basin, right? Only water vapors, rises upwards, so it leaves behind all the kind of impurities, including the microbes. A solar still effectively eliminates all waterborne pathogens, salts, and heavy metals that other expensive and complex method can't do. Moreover, you see, the sun rays also contains some amount of UV rays. So this UV rays are also helps in killing the germs, right? So this is all about the basic principle of basic working principle of the solar distillation process. Now let's move to the next topic, that is the construction of the solar still, right? So I will explain this construction with the help of these bullet points, right? First bullet point says the solar still consists of a horizontal basin tray. So here you can see that this black line, this is a tray, right? This is the basin, and just at the basin, you can see that there is a basin tray. Consists of a horizontal basin tray, triangular side walls. The side walls are triangular or trapezoidal, you may say, and sloping glass cover, right? Now the basin tray is made of stainless steel, and its inside surfaces are painted black. The basin tray is made of stainless steel because it contains the water. So in order to avoid any kind of corrosion, it should be made of the stainless steel, and it's all inside surfaces. Sides are painted black, and at the bottom of this basin tray, it is covered with the black butyl rubber liner. Why? Um, it is covered with the black butyl rubber, or the surfaces are painted black in order to enhance the absorptivity of the solar radiation. So all the radiation that you see, the solar energy is not absorbed in the water. Solar energy, you see, is converted into the heat only if the photons in the solar energy are strikes on any surface. Then these photons are converted to the energy. The solar energy is not converted into the heat as it passes through the water. Only a small amount of the solar radiation is converted to the heat. So most of the energy, when strikes on these sides or the bottom of this basin, it gets converted to the heat, and then this heat is then eventually transferred to the basin through convection process, right? So this basin tray becomes heated because it has all the black surfaces. So heat from it, this basin tray is transferred to the basin water through a convection process. So this is how the temperature of the basin water rises, right? The triangular side walls are made of stainless steel with mirror polished basin side surface. Now, why they are made of stainless steel with mirror polished basin side surface? Let me go back to the prototype of steel. So here you can see that this is the triangular side. Now, inside the surface towards the basin side, the inside surfaces are made of mirror polished surface, so that any radiation which strikes on this, which enters through the glass, but it strikes on the wall, will be reflected towards the basin, right? So this is that is why the inside surface of these side walls should be made of reflecting surface, right? Now again, coming back to the original bullet point, the triangular side walls are made of stainless steel with mirror polished basin side surface. The glass cover is oriented towards south direction. Okay, so this is facing the south direction, this glass cover, and it is sloped at an angle equal to the latitude angle of the place for capturing maximum solar radiation around the year. So this I had already explained in one of my previous lecture, why the soul any receiving surface should be inclined, should be oriented toward the south direction, and why it should be inclined at an angle latitude. It should be inclined at an angle equal to latitude angle of place for capturing maximum solar radiation, right? Now, next point is the distillate connecting channels, that is trough, or the connecting collecting channel, is made of polycarbonate sheet. It is normally made of polycarbonate sheet, and it is attached with appropriate slope at the lower edge of the inner surface of glass cover to collect the distillate. So this I had already explained that this channel, I again go back to the prototype. So this is the lower edge of the glass cover. So at the lower edge, beneath this glass cover, a distillate channel is there with a certain slope from here to here, right? And this this, this channel is fixed to the glass cover with the help of silicon tube, right? The next bullet point is the plastic pipe is connected with this channel to carry the distillate water to the collecting flask. So from this collecting channel, a plastic pipe is connected, which carries this pure water to the this container, right? Now the framework of the still is made from with the mild steel, and all the outer surfaces are well insulated with thick polyurethane foam in order to minimize the heat losses from steel. You see, as I said that the inside surfaces of this steel are made of stainless steel and mirror polish, but outside of this steel, that is the framework of the steel, you may see that here you have it's a kind of wood structure, or it may have a certain, you know like it is given that it is covered with the thick polyurethane foam in order to minimize the heat losses from the inside of this enclosure to the outside through these side walls or the bottom, so the maximum energy is utilized to heat this basin, right? Wood can also be used to fabricate the framework of the steel, as it is a good insulator. So at the outside of this steel, for the framework, the wood can also be used, because wood is we all know there is a good insulator, so it will prevent heat losses from the sides. However, due to deterioration of wood in external weather conditions and due to continuous contact with vapor in water, such steels are very less life life cycle, 2 to 3 years. So wood is used as a framework, then the life cycle will be very low, because what the wood gets deteriorated with time due to extreme outside weather conditions. Now let's move to the next topic: quality of water obtained from solar steel. You see, the distilled water from solar steel does not acquire the flat taste of commercially distilled water, since the water in solar steel does not boil. Boiling actually lowers pH. So let me explain what is this thing. Let me go back to the figure again. Okay, this is the figure. So first let me explain what is boiling and what is evaporation. You see, if the water has to be boiled, then the water temperature has to be reached to be is to be heated to 100 degrees centigrade. Then what happens if if the entire bulk of the water is heated to 100 degrees centigrade, then the vapors are formed from the entire bulk. So boiling is a volumetric phenomenon, right? It happens throughout the volume. But evaporation is a surface phenomenon. At any temperature, uh, the water particles from the free surface, you know, always have a tendency to escape from this surface to move to the free space, right? Now higher the temperature of this water, higher will be the tendency of the particles lying on the surface to escape into the free space, right? So in the case of solar cell, the temperature does not reach to 100 degrees centigrade. Its temperature, maximum temperature reached is around 75 degrees centigrade. But as I said that the evaporation continuously takes place. Like for example, the water from the many water bodies on the earth, like river, pond, it continuously evaporates. But this evaporation, this dry, the ponds gets dry, but they don't get dry because of the boiling. It is the evaporation phenomena which makes the ponds dry during summers, right? So in the case of solar cell also, this the river formation also takes place because of the evaporation process, right? And evaporation is a surface phenomena. So what happens that when the boiling when distillation is done by using the boiling process, that is if the entire fluid is heated to a boiling temperature, then the boil then and after that, if that vapors after boiling are condensed, then you get the lower pH value, right? Boiling actually lowers pH value. While in case of solar still use natural evaporation and condensation process, which is also the rainwater process. This allows for natural pH buffering. Now, what is natural pH buffering? It is a chemical phenomena that I am not explaining here, right? You can refer uh, any book or Google, you will find natural pH buffering. But if this distillation is taking place by using the evaporation process, then it is a kind of natural process, and this natural pH buffering, gives excellent taste as compared to the steam distillation. Steam distillation means the vaporization is not taking place because of the boiling, right? So what happens? You see, uh, if the pH value is high, as in case of sorry, if the, if the pH value is low, then it gives a flat taste. Whereas in case of natural pH buffering uh, case, like in case of solar still or in case of a natural hydrological cycle, the pH value is related. pH value of the distilled water after condensation is high. If the pH value is high, then that means the solution is basic, and a water with basic uh, characteristics, that is higher pH value, gives a sweetening taste to our taste buds, right? So it does not, so the distilled water that you get from here is not as flat as you get the commercially distilled water that you use for the water that you use for the batteries. So here you have a basic water with basic characteristics that gives a sweetening taste to your tasting buds, right? The process of evaporation and condensation in solar cell removes impurities such as salts and heavy metals, as well as eliminates microbiological organisms. The end result is water even cleaner than the purest rainwater. So why it is even cleaner than the rainwater? The reason is that let me again go back to the uh, schematic diagram solar cell. You see what happens in case of rain when the rain comes down from the cloud to the earth. So it passes through the water drips passes through the atmosphere, and atmosphere is full of all kinds of dust and microbes and germs. So as the water drips down from cloud to the earth, it again captures all absorbs all kind of germs. While in this case, the enclosure is free of any impurities. So when water is condensed, you get a water which is even purified than the rainwater, right? Next is third point. Some people question the suitability of drinking distilled water because it has been robbed of its mineral content needed for good health, right? Yeah, it's right that now it does not contain any mineral content because everything which is solid is left behind, right? The answer to this question is that it is better to drink purified distilled water rather than drinking impure water, right? As drinking safe and pure water is our best protection against ingesting a host of toxins and pollutants that are serious threats to our health. People can supplement their need of mineral content by eating nutritious foods, especially fruits and vegetables. So what I want to say is that if suppose you don't have a pure water at any cost, you have a contaminated water and you are at a place where there is no way to pure the water, so it is better to use the solar still to convert into a pure safe distilled water, so that at least you will not inhale or ingest or intake the toxins or pollutants, and you can supplement your mineral content by eating a nutritious food, right? Now classification of solar cell on the basis of solar cell shape of the solar cell and method of heat supply to the base inverter. The solar cell can be broadly classified as single slope and double slope solar cells, passive and active solar cells. So I will explain both the types of solar cells one by one. So first, single slope and double slope solar cell. So here you can see the figures of this figure one, so the single slope solar cell that we have already shown in previous pages, and this is the double slope solar cell. So the one obvious evident difference you can observe here is that in single slope solar cell there is one glass cover with a single slope, whereas in case of double slope solar cell there are two glass covers sloped at uh, so there are two uh, and they are sloped at different angles, different orientation. So this double slope glass cover solar cell. So what are the merits and demerits of this type of solar cells? So let me read from uh, first bullet point. Single slope solar cell consists of a single sloped glass cover, sloped at an angle equal to the latitude angle of the place, and the glass cover is oriented towards south to let the solar radiation enter into the still throughout the day. Right? Okay. So this is only there is only one glass cover, and all the radiation gets in through this single glass cover. On the other hand, and there is also one observation here that the directions are shown here. So east west, the sun from morning moves from east direction, then and then crosses it, and then sets in toward the west direction. But I have already explained in one of my lecture that the path of the sun in the sky is a little toward the south direction. So this glass surface is always oriented toward the south, so that the, it always receives sun radiation from morning till evening, right? Now, in case of double slope solar cell, what happens? Now, here you can see that. Let me first read out the second bullet point. On the other hand, double slope solar cell considers a double slope glass cover oriented towards east and west to receive the maximum radiation. In this case, when the position of sun is on the east in the forenoon, the west facing glass surface is cooler than east facing one, and hence relatively higher condensation takes place on the west facing glass cover and vice versa in the afternoon. Let me explain it with the help of this figure. See, so uh, this is how the double glass covered solar cell is kept. It's one of the glass cover is oriented toward the east, and the other glass cover which is in this direction is oriented towards the west. So unlike in case of single slope solar cell where the glass cover is inclined toward oriented towards the south direction. So what happens when the sun moves from east to west like this? So in the morning the the sun radiation enters to the solar cell enclosure through this glass cover, right? And so what happens And by the way, and after the noon, that is in the afternoon, when the sun reaches towards the west direction, the sun radiation enters to the solar system through the west glass, right? Now, what happens in the morning, that since the sun is entering, the radiation is entering through this glass cover, and the sun is facing this side, so the temperature of this glass surface is slightly higher than the temperature of other glass cover, which is facing, which is oriented toward the west direction or the west oriented. In the morning, the glass cover which is oriented toward the west has a relatively lower temperature. So you see, now what is causing the distillate to be produced here, condensate to be produced here? It is the because of the temperature of the impurity is being evaporated, and then it is condensed. So higher the temperature of basin water, higher will be the evaporation rate, and lower is the temperature of the glass cover, higher will be the condensation rate, right? If the glass cover temperature is also high, then condensation will not take place as fast as it should. So what happens in this case, that in the morning, since the west oriented glass cover has lower temperature, so relatively higher distillate or condensate is formed on the west facing surface in the morning time, in the forenoon time. And when sun reaches to other side in the afternoon, in the west, so the west facing surface will have higher temperature, and this east facing surface will have lower temperature. So obviously condensation will take place more in east facing surface. So what I want to say is that the condensation takes place in both the surfaces. That is why you may see from this diagram there is a collection channels at the bottom edge of both the glass covers. And here you can also see that, uh, so this is the lower edge, that means this is the lower edge of this glass cover. So here you have a uh, distillate collection channel, and this is the outlet. And likewise, uh, on the other side, which you cannot see, there will be a collection channel, and the outlet of that collection channel you can see over here. Then both the outlets are clubbed together, and then through a single outlet the pure water is collected in this container, right? So I then so again read out second point, bullet point. On the other hand, double glasses still consider double slope solar still oriented towards east and west to receive the maximum solar radiation. In this case, when the position of sun is on the east in the forenoon, the west facing glass cover is cooler than east facing one, and hence relatively higher condensation takes place on the west facing glass cover. So this is what I explained just now, and vice versa in the afternoon, right? The material required for the production of double slope solar steel is less than that needed for single slope steel for the same basin area due to absence of back vertical wall in case of single solar steel. So here you can see that for the same basin area, that is basin is this one, right? So this dimension and multiply by this dimension. If the this basin area dimension of both the steel is same, then lesser material is required in case of double solar steel, because in this case, uh, double slope solar there is no backfall as such as in case of a single slope solar steel, whereas the glass cover requirement is almost the same, right? And then furthermore, productivity of double slope solar cell is higher than single slope solar cell because one glass cover is always at a relatively lower temperature, right? So what happens in this case, in a single slope solar cell, this glass cover is always exposed to the sun, so it always has a reasonable temperature, reasonably high temperature. So condensation is not always high in this case throughout the day, whereas in the case of double slope solar cell, in the morning one of the glass cover is at a lower temperature, in the afternoon the other glass cover has a lower temperature, so condensation is quite good in the case of double slope solar still, right? No, passive and active solar still. So as I said, the solar cell can also be classified into two: passive and active solar still. The passive stills receive direct solar radiation as a source of energy, while in active stills, additional heat is supplied to basin water from external sources such as flat plate collector, concentrated collector, evacuated tube collector, and solar pump. Right. So all the solar cell cases that we have already discussed so far now, or the passive solar cell, because they receive solar radiation this uh, only from the source, right? Whereas in case so there is no external source of heat supply to the basin water. Whereas in case of active solar cell, additional heat is supplied to basin water from external sources such as flat plate collector. Like in this case here, one of the example of figure of uh, active solar cell is shown, where uh, the additional heat to the this saline water whatever is supplied through this flat plate collector over here. So here you can see that the basin water is is being is being circulated through solar collector, and then it again goes to the basin. So here the basin water receives the direct radiation, as well as when this basin water circulates through the solar flat plate collector, it also picks heat from here. So this is how the external heat is also supplied to the basin water. Now in this case, you see the requirement, water's requirement of this pump is very low, because the water is to be you know circulated with very low flow rate, because so that the water gets enough time while it passes through the solar collector, so that it can be heated, right? So very low flow rate is required. So very low power pump is required, hardly of 60-watt pump. And this pump, the energy for this pump can also come from the solar panels. So like 60-watt valve, 12 volt and 5 ampere direct current DC pump can be used, and the power to run this pump can become from the solar panels through photovoltaic process. So not as such the conventional energy used. So this energy is also the energy also used to run this pump also come from the sun, right? So this concludes this topic.